All right, welcome. Today we are going to pull back the curtain on the invisible world that connects everything we do online. We're talking about network topologies, the actual blueprints for how our digital world is built. And trust me, why you choose one blueprint over another, well, it matters a lot. Let's dive in. Have you ever just stopped and thought about it? Your laptop, your phone, your TV, your smart speaker, they all just talk to each other seamlessly. You're streaming a movie, firing off an email, jumping on a video call. It all just works, right? Well, there's a secret behind that magic, and it all comes down to the network's blueprint. So let's start with the basics. What even is a network? At its simplest, it's just a bunch of devices connected together so they can share stuff. But the how, well, that's where it gets really interesting. That's the blueprint, or what the pros call a topology. You know, this isn't just some random jumble of wires. A network's topology is a very deliberate design, and here's why you should care. That design directly impacts how fast your connection is, how much it costs to set up, and, this is the big one, how reliable it's going to be when you need it most. Okay, so we're going to walk through the 5 main types of these blueprints. We'll start with the most basic and work our way up to the really complex, heavy-duty designs you see out there. First up, the most fundamental of them all, the bus topology. It's super simple. Every single device, your computer, your printer, everything is hooked up to one single main cable. So picture this. All of your data is like traffic on a single highway. If your computer wants to send something to your printer, it just puts it out onto that main road, and it travels down the line until it finds its exit. And right away, you see the trade-off. On one hand, it's super cheap and easy to set up, perfect for a small, simple network. But that single highway is also a single point of failure. If there's a break anywhere in that main cable, the entire network grinds to a halt. Everybody's stuck in traffic. All right, next up is the star topology. And I'm willing to bet this is the one you actually have in your home right now. It is by far one of the most common setups. Every device connects directly to a central point like a hub or a switch. The best way to think about it is like a traffic roundabout. Data from your laptop goes into the middle of the roundabout first, and then the hub directs it down the right road to get to its final destination. And this is where the StarNet really shines. If one device goes down, let's say one road is closed, it doesn't affect anyone else. The rest of the traffic just keeps flowing. The downside? And there's always a downside, right? If that central roundabout fails, the whole system goes down. No one's going anywhere. Okay, let's talk about the ring topology. Now, like the name says, every device is connected to 2 others, which forms this continuous closed loop. You don't see this one as much these days, but it's still out there in some specialized settings. In a simple ring, data travels in just one direction. It gets passed from device to device, kind of like a relay race, until it gets where it needs to go. It can be pretty efficient, but it has that same fatal flaw as the bus. If there's a break anywhere in that loop, the entire ring is broken. Okay, now we're getting into the heavy hitters. Meet the mesh topology, the absolute powerhouse of reliability. In a full mesh, every single device is connected to every other device. It's a true web of connections. This is like a perfectly designed city grid. If one road is blocked, who cares? The data has tons, maybe even hundreds of other possible routes it can take to get to where it's going. This makes it unbelievably resilient. So, with all that power, what's the catch? Well, it's pretty obvious when you think about it. All those wires and connections make it incredibly expensive and really complicated to manage. That's exactly why you only find mesh topologies in places where failure is simply not an option, like in hospitals or for military communications. So what happens when one of these blueprints doesn't quite fit what you need? Well, that's where the hybrid topology comes in. It's not really its own type, it's more of a custom-built solution that combines 2 or more of the others. This is basically the mix and match approach. It lets network designers get really creative. They can build a star network for one department because it's cheap and easy to add people, and then connect that to a super reliable mesh network for the company's critical servers. It's all about taking the best of all worlds to build exactly what you need. Okay, that was a lot to take in, so let's kind of zoom out and put all of this together in one place so we can really see the big picture. Just look at this table. It lays out the trade-offs perfectly, doesn't it? You can see the pattern clear as day. As you go from a simple bus to a complex mesh, what happens? Cost and complexity shoot up, but so does reliability. It just goes to show you there's no single best choice. It's always a balancing act. Okay, theory is great, but how does this stuff actually play out in the real world? Let's look at a couple of quick practical examples. Remember that little central box in the star topology? Well, it can be a dumb hub or a smart switch. A hub is kind of like a town crier. It just shouts the data out to every single device, whether they need to hear it or not. A switch, on the other hand, is like a postal worker. It knows exactly where the data needs to go and delivers it only to that one specific address. It's way more efficient and secure, which is why pretty much all modern networks use switches. And here's where it all comes together. Imagine a typical office. The marketing team, they're probably on a star network. Why? Because it's easy to add a new desk and a new computer as the team grows. But the company's main servers, the ones that absolutely cannot go down, they're going to be on a rock-solid mesh network for maximum uptime. See? It's all about picking the right tool, the right blueprint for the right job. So what's the big takeaway from all this? It's that choosing a network blueprint is all about those trade-offs: cost versus performance versus reliability. You have to know what matters most for your situation and then pick the design that fits. And that leaves me with one final question for you. The next time you're at home or at the office, look around. Think about how everything's connected. Based on what we've just talked about, can you guess what kind of blueprint your own network is built on? Thanks for joining me.